Good evening, everyone. Welcome to another episode of the Star Stream from Focus Astronomy. If you've never joined us before, appreciate having you here. We do this once a month right here at the Skywatcher. I do the webcast way too often for too many places. Welcome to Starstream. Starstream is a virtual star party that takes place right here online at the Focus Astronomy YouTube channel. We do these monthly. They're free, they're interactive, and they are live. So everything you're going to see tonight off of our telescope is broadcasting to you live from that telescope. And just to show you guys what we're looking at tonight, let me switch over. Here is our observatory tonight. This is the Falling Eagle Observatory in Bradley, California. It's part of the Skies Away remote observatory facilities. And we've got two telescopes in the observatory. The closest telescope to the webcam there is a friend of ours. Hi, David, if you're watching. That is his telescope there. It's currently parked. I don't know if it'll be running this evening. And then the telescope we'll be using tonight is the North Pier, which is the telescope that is pointing up at the sky right now. It's currently doing an autofocus run while we're talking. That way it can get nice, sharp images tonight. Just to kind of go over what the equipment that we're using this evening is. We're using a Skywatcher Esprit 150. That's a 6-inch triplet refractor. And what I mean by triplet is there are 3 elements of glass in the objective lens that allow us to get very sharp, high-resolution images, as well as very well color-corrected images, so there's no color aberrations or weird fringing that'll occur when we're taking these really dramatic images of the nighttime sky. That is riding on a software bisque Paramount MX. It's a robotic telescope mount. It allows us to basically track objects as they move across the nighttime sky or whenever. At the back of the telescope, we currently have a ZWO 6200 camera. I actually have another one right here. This is the ZWO camera. It's a CMOS camera. Uses a full frame sensor in there, so big chunk of hardware right there. It's a 61 megapixel sensor. The one I have in my hand right here is a color version, but the one we're using on the telescope out there is a let me just see how we're looking with everything here. Cool. We're all focused. Don't mind the webcam. It's pretty delayed. So don't mind looking at that. So basically, that's what we're using tonight is, let me transition back to me, is we're going to be using one of these big monster full frame cameras to do our observing. And then on the back of the telescope, just in front of the camera between the telescope, there's a weird disc looking thing. That is a filter wheel. And inside a filter wheel, it kind of varies between setup, but our filter wheel has 7 filters. These are smaller versions of that. And basically what's in there is we have a luminance filter, which is right here. It's kind of a clear filter where you take a lot of your structure and your detail. We have red, green, blue. That's how we take color images with a black and white camera. We shoot through a red filter, a green filter, a blue filter, and that allows us to isolate the certain details that we see in those filters in our image. And then we have what are called narrowband filters, which are these little mirror looking filters right here. So we have hydrogen alpha, oxygen 3, and sulfur 2. These isolate certain wavelengths of light that we want to study with our telescope that are generally emitted by certain objects in the nighttime sky, and we'll be able to play around with those a little bit. These are much smaller filters than what we actually have in the telescope. These are standard 1.25" filters, which are generally paired with fairly small sensors. The telescope out there, because it has such a large camera on the back, needs much larger filters. So we are using 50 millimeter square filters, which are big chunks of glass that sit in there. And that's what's going to be allowing us to filter and isolate certain wavelengths of light. So yeah, that's what we're using tonight. Let's bring up the telescope and get started. Now, if you have any questions, there is a chat live. If you need to say anything, have any questions, just want to interact with each other, feel free to talk amongst yourselves in the chat. It's cool to have you guys here. I'm going to go ahead and close the webcam. And then I also have Stellarium up. If you're not familiar with Stellarium, it's a planetarium program. It's free. You can go online. You can get it. It's a cool thing just to see what's up in the nighttime sky. So this evening we've got Saturn, which is currently setting right now. It's low in the western sky. We have Jupiter. We have just about a right about first quarter moon up right now. And then we also have the planets Uranus and Neptune. I'm not quite sure if Neptune is up quite yet. But Uranus, because Uranus is in our observing list tonight, we're going to give that a shot. But the constellations we're going to be messing around in tonight will be, of course, Cygnus the Swan. We'll be hanging out in Pegasus, Andromeda. Of course, we're going to spend a lot of time probably in Orion towards the later part of the evening. Perseus, and then we may dip way down here into the south, down near Fornax, and some other interesting stuff way down here in the southern part of the sky. We'll see what the telescope can do this evening. Now, we are doing a process called live stacking. So what that means is the camera is going to continually take pictures over and over again, applying them on top of each other, which basically will be equivalent to a really long, deep exposure, allowing us to see all kinds of faint details. So that'll be kind of cool as well. So without wasting any more time, let's get started. Let's see, our first target tonight, if the software and everybody's going to play nice. We're also using a Prima Luce Eagle for all you equipment nuts out there. This is the computer that runs everything this evening. You can turn everything off and on remotely, which is very nice since I can't actually be there. Let me go ahead and there we go. See if we're good to go. Perfect. I think we're good. All right, so first object of the night is the Veil Nebula. It's one of my favorite objects in the entire night sky. It's a supernova remnant, and while the telescope is making its way over there, I'm going to bring this up. Oops, there we go. Bring this up over here. This is normally a summertime object, so it's really low. It's getting really low. We're really scratching the what we can get out of it. So it's right over here, right about there, in the constellation of Cygnus. So Cygnus is this big swan constellation, also known as the Northern Cross. It's very, very easy to find, especially in the summer months around June, July. It's nearly overhead, but right now it's setting, and right over here in the eastern wing of Cygnus, right over here, is this supernova remnant, and it's massive. The Veil Nebula sits about 2,400 light years away from the Earth, and it spans 53 light years in diameter. Here on Earth, however, it spans about 3 degrees of the nighttime sky, which is about equivalent to 6 full moons. So we're going to have to take this in pieces because the telescope that we're using tonight does not have the capability to swallow that much of the sky. So we're going to get our camera going here. Live stack. There we go. And what we're going to do here is we're actually going to use one of our narrowband filters, like I was talking about earlier. And these narrowband filters are going to isolate a certain wavelength of light. And this one happens to be, of course, nothing wants to listen to me. Good old software. Let's see if we can restart this real quick. We've had the telescope off for a few days now because of some storms that were in the area. So now, of course, everything wants to be all buggy. So hang in with me just a second. And we'll get it all going again. If you've ever done astrophotography, this is exactly how it works. A lot of times everything works nicely, but every now and again it doesn't want to play nicely. So we'll just restart everything. Do you try turning it on and off again? That's always a good way to start. While we're doing that, getting all this back up and running again, the Veil Nebula is a supernova remnant. And what that means is we had a very, very large star at the end of its life that eventually could no longer hold up against the force of its gravity, and it was pulled in, and the amount of pressure that comes in basically ricochets back out, detonating the star. Very, very violent event. Let's see if this works now. Hopefully it plays nice and I won't have to call in the big guns to go out there and smack the telescope for me. But again, the Veil Nebula is a supernova remnant, very, very violent explosion. It was originally discovered by William Herschel in 1784 with an 18-inch telescope. For those of you who aren't here in the U.S., that basically is about a 0.45 meter, just under half meter diameter telescope. So fairly good size, especially from an amateur level. That's a pretty decent sized telescope. Okay, it's playing nice now, finally. But 18-inch telescope, which actually gives you a very impressive view of the Veil Nebula, ultimately, especially from a dark sky site. Now, if you're viewing the Veil Nebula, especially if you're doing it visually, photographically, it's a lot easier to do because cameras are much more sensitive than the human eye, where if you want to do it visually with your eye, you're going to need a decent telescope, decent aperture telescope that is basically going to gather enough light. What's going on here? Nothing wants to listen to me this night. Let me switch the filter wheel. There we go. All kinds of technical fun tonight. Now it's listening. Cool. Hopefully we're good the rest of the night. So, Veil Nebula, supernova remnant in the constellation of Cygnus, discovered in 1784 with an 18-inch telescope by William Herschel. Because it's such a large structure, it is composed of, it has multiple designations on this. So, the Veil Nebula has a couple different a couple different sides of it. Currently, we are on the western side of the veil. And hopefully, okay, so it's just starting to show up here. And this is why we're going to start stacking images, because it's very, very faint. I'm going to try to stretch this a bit. We're also pretty low in the sky right now. There's the, this will look cleaner as well as the evening progresses, because it's going to stack more and more images. But this is a single 30-second exposure, which if you're used to, like with your phone, you take a picture, it's usually, click, done. We're doing long exposures, so the camera shutter is open for 30 seconds. At least that's what we're doing this evening. It's open for 30 seconds. But most of the time, even my mic doesn't want to stay put tonight. What the heck is going on tonight? I'm not going to hold this for an hour and a half. Okay. My life is falling apart this evening. Anyway, so we're taking long exposures tonight. So the shutter of the camera is actually opened up for a long period of time. So rather than just a simple click and you're good to go, we're shooting 30-second exposures, which is still rather short for astrophotography. Normally, for something like this, we'd be taking 5-minute, 10-minute exposures, letting all that light build up on the sensor. So what we're doing tonight is kind of a watered-down version, if you will, of standard astrophotography. And the software that we're using is stacking that over and over and over, making the image brighter and easier to see. So the particular part of the Veil Nebula that we're on right here, this is called the Western Veil, or the Witch's Broom. You can kind of figure out why. It does look a lot like a witch's broom, which is actually kind of neat. And we are using our hydrogen alpha filter, so that is eliminating everything except a very deep portion of the red part of the spectrum, which just happens to be a particular wavelength of light that this particular nebula emits heavily in. So estimates from observations kind of put this between 5,000 and 8,000 years old. And this particular portion of the veil is known as, like I said, the Western Veil, NGC 6960. And there's multiple pieces of it, and I'll try to bounce around with it. It's pretty low in the sky, so that's probably why we're going to have some challenges observing it. But you're starting to see more and more of that detail come out, which is very impressive for this type of setup. So I'm going to stop it right there, just because we're kind of asking a lot from the system, being that we're shooting so low. Generally, when you're doing astrophotography or you're observing, you want to stay away from the horizon because there's a lot of heat coming off the ground. There's a lot of dirt and particles in the air, so you're shooting through more layers of air than we would shooting straight up. Tommy, what gases is the nebula composed of? The nebula is composed up of hydrogen. There's also some double ionized oxygen, as well as some other particles in there as well. And what we're using right now is an H-alpha filter. So we're actually highlighting just the hydrogen portion of this nebula is what we're observing right now. But there's other wavelengths that you can isolate in this particular object as well. There's an abundance of different things in this nebula, but most nebulas up there are composed about hydrogen. That's the most common element in the universe anyway, so that kind of works out okay. So we're going to move to the middle part of the Veil Nebula. The center part of the Veil Nebula, it's known as Pickering's Triangle. And while we're doing that, I'm going to bring up a really high resolution image that I've shot of this nebula. If you'll bear with me real quick while that's doing that. I know nothing's on the monitor right now other than my backdrop screen. But I'm going to bring up a real high resolution full image of this object so I can kind of explain where we're at with different things. Let me pull that up here. I think I even have it labeled. Yep. It's a big image, so it takes some time to load this thing. All right, here is the entire Veil Nebula. This was actually taken off the telescopes that are in the observatory that you see there. So we're looking right down here. This is NGC 6960. This is also a color image, by the way, so that's why you're seeing color. This is the Western Veil that we were looking at, NGC 6960. We're now over here in the center portion, which is Pickering's Triangle, and then we'll move over here to the Eastern Veil, or the Network Nebula is what also it's known. That's NGC 6992, 95, and then the tail end is 1340, the catalog number from that. And this whole massive structure, which I said is the diameter of 6 full moons in the nighttime sky, is the Veil Nebula, a massive supernova remnant that was left over from the death of a very large star. So that's what we're doing right now. And Pickering's Triangle is a lot fainter, and because we're so low, it's going to be a challenge. But you can kind of see it coming out there, right in here. So this is a very large area of the nighttime sky that we're working with. And I'm actually going to cut this one short too, just because this one was going to be kind of a stretch because of how low it was in the sky. There's a lot of better option targets I have on the list this evening that are going to be able to show up better and show you what this system can actually do. So we're going to finish up this really quick, and then we're going to flip over to our next target, which actually is a bit higher in the sky. It's also a lot easier to see. It's actually one that you can go out in your backyard as long as it's clear and you can see, where the Veil Nebula requires a little bit more effort, darker skies, better conditions to actually get. So why wrap this one up? I've actually moved the telescope over to NGC 6992 and 95. That's that Eastern Veil portion I was telling you guys about a minute ago. It's also the brighter of the three portions of the Veil Nebula. And a lot of the structure that you're seeing, these really elegant wisps that will be inside of here, are something that you can actually see in a dark sky sight, probably with a 12-inch telescope or bigger. If you have access to a 20-inch telescope, it's actually mind-boggling how awesome it is. Here is the Eastern Veil. Try to stretch this out a little bit. But there's the Eastern Veil right there. Really a lot easier to see. Again, it's very low in the sky, so we're not shooting in a great position, but you can still see that structure there. And a lot of that structure you can actually see visually. Now, one of the cool things about supernovas is if you ever look at the periodic table of elements, you know, hydrogen, helium, oxygen, all that fun stuff that makes the periodic table of elements, all of that is formed in a star. That's the only place in the universe you can actually make an element, at least down to iron. Most stars like our sun will form all the way down to, well, stars about the size of our sun will form down to about carbon, and then a little bit larger stars can actually go down to iron. Now, after a star gets to iron, it cannot, the nuclear fusion process that fuses lighter elements into heavier elements can't make any more elements. It just doesn't have the pressure, it doesn't have the heat to be able to produce the heavier elements in the periodic table. Now, a lot of people that I've talked to at events, I'm sure many of you out there, if you wear jewelry, maybe you have like a wedding band or earrings or what have you, something that's gold, silver, platinum, all of that material, the molecules that make up all that jewelry that many of us spend so much money on, gold, silver, platinum, for instance, cannot be made naturally in a star. The only time you can actually make those elements is in a supernova, because of the immense heat and pressure that has occurred when that star detonates. So during that period of time, that rapid acceleration that's actually occurring there, we finally have the right conditions to be able to form these heavier elements. And that is where the molecules and the atoms that make up gold, silver, and platinum are actually formed. So next time you pick up your wedding ring, or next time you put your earrings in, or wear that necklace, or you step in a jewelry store is a good example of this, you're basically stepping into a store full of supernova remnants that you can see there. So really kind of cool. And that's really the only place in the universe that you can actually make those atoms. So it's kind of a cool thing there. So you can see now that's really starting to come through a lot better. That is the Eastern Veil. NGC 6992 is this portion right here. NGC 6995 is right over here. And then IC 1340 is the back portion right there, also called the Network Nebula. That is the Eastern Veil. Awesome summertime object, but it's just right now it's not something that we're at the very, very edge of the season to get the Veil Nebula. So very cool object to see, one of my favorites, but we're pretty much saying goodbye to it this evening because it's just about to set. So I'm going to go ahead and stop that. That wraps up the Veil Nebula of this portion. And now we're going to head a little bit higher into the sky and get something a little bit easier to see. It's also an excellent object that, you know, maybe you're going to get a telescope for the holidays. Maybe you just got started in astronomy. Maybe you just have a pair of binoculars that you want to go out and do some observing with. This particular object, also known as the double cluster, is phenomenal and all those things. So let me actually show you where the double cluster is. It's in the constellation of Perseus. And we're going to be quite high in the sky on this one. The double cluster, like I said, is in the constellation of Perseus. The hero actually sits right in between Cassiopeia and the constellation of Perseus, as you would see them in the nighttime sky. And in a dark enough location, and it doesn't have to be that dark, you can actually start to see the glow of the double cluster naked eye. And in a very dark sky, it's quite obvious how easy it is to see. Now, this one doesn't need any specialty filters either, because we're just looking at a star cluster. So we're going to go ahead and flip our filter to what's called our luminance filter, which lets all colors of light through it. It's not isolating any particular... we're not isolating anything in particular at this point. We're letting all the visible light through. And of course it wants to be challenging again. So let me go ahead and exit this real quick. Usually this is really smooth, but of course you turn everything off and then it gets all funky on you. So let me see if I can get everything to play nicely again. Thanks for hanging out with me tonight. Let's see what's going on here. Okay, now let's see if it'll talk. There we go. Now I have to move all these filters around. Filter wheel. Switch you off. So a big thing when you're doing remote astrophotography, which means you are nowhere near where your telescope actually is, having a system where you can turn on and off different hardware is a big deal, because you can't just go outside your backyard and unplug a USB and then be back in the game again. And that's something that's important to have on something like this. So it's nice that we have all that capability here, so we can basically smack the telescope into acting correctly while we're doing it. Oh, man. It does not like me tonight. Last month we were super smooth, and this month it just doesn't want to talk and play nice on anything. So anyway, while I'm resetting the software again, we're going to go over to the double cluster. Double cluster is two open clusters in the constellation of Perseus, the hero. This is a very easy object that you can see even from a basic dark sky site, not far out of town. And it looks great in binoculars. Actually, if you go out tonight, if it's clear where you are, you can actually get a nice view of that. So my buddy Brian, who runs the observatory, is going to be out there working on it real quick just to get it working. But the double cluster sits about 7,500 light years away from the Earth in the constellation of Perseus. That's kind of at the outer arm of the Milky Way galaxy at this point. Not much further beyond the double cluster is basically intergalactic space at that point, because the arm of Perseus is kind of one of the outer arms of the Milky Way. So not much further than that, we're getting pretty deep out into space at that point, extra galactic at that point. There's a lot of orange stars that are inside of this cluster. So if you actually go out and observe it with a telescope, or you're shooting a color camera or something like that, this is a object that you're going to be able to see those orange stars. And the reason why that's important is orange stars generally are older in their life. So they've been around for a while. It generally, I'm sorry, lost my train of thought on there. It generally has been around for quite a long time. So knowing the colors of the stars can actually kind of tell you a little bit about the age of a cluster. Okay, hopefully everybody's happy now. We can get this show back on the road the way it should be doing. Gonna get our telescope hooked up. Tommy, the telescope is located in Bradley, California, at a location called Skies Away Remote Observatories. They're a great hosting facility, and basically you send your telescope and your equipment out there, and for a monthly fee, you have access to dark skies all the time, no matter what. So it's kind of a cool thing to do. It's kind of an advanced astrophotography setup at that point. But it does have its perks, because obviously a lot of us can't get out to dark skies all the time, so having your telescope situated remotely gives you access to that. And I think everybody's ready to go again. So let's see if everything plays nice now. And we can go find our target and get back on track with this. So, while the telescope's going over the double cluster kind of has an interesting history about it. It was originally documented by the Greek astronomer Hipparchus in 130 BC. But it wasn't until the 19th century that William Herschel observed the cluster through a telescope and actually confirmed that it was indeed two clusters of stars. So it's kind of a cool history there. I'm going to try to actually get this thing to let us do what we want to do this evening. Please play nice. When the camera starts, you're going to notice the exposure bar is going to start. That's the download for the camera. So it's moving the filter right now. Hopefully everything is nice and it'll start. There we go. That's what we want. Finally. So now it's on the double cluster. Hopefully we'll get a nice picture of it and we can kind of start back on the momentum that we were going there. Thanks for being patient and understanding with it tonight and hanging in there. Just the challenges of using some of these systems. Even if it's in my backyard, it can do the same thing. But the double cluster is a beautiful cluster that you can see from your backyard. A small telescope will do a great job on it. But if you get to a darker sky, you can really see how immense the cluster expands out into space. There's actually two of them in this. There we go. There's a beautiful shot of the double cluster. These are the two. They have their own NGC numbers. You have NGC 869 and 884. That's basically the two clusters, but a lot of people just know them as the double cluster because they generally are going to fit in the same field of view. And they're very easy to see. So because they're so closely packed to one another, generally you're observing them almost as one object, thus the name double cluster. It's a great binocular object. You don't need a lot of aperture to get a view of these clusters, and especially a nice view of the clusters. 50 millimeter binoculars are more than enough from an average backyard. You can see them. From a dark sky site, those binoculars are going to show a dense star field. And then, of course, if you have a larger optical system like a telescope, maybe like a 6-inch telescope or an 8-inch telescope, you're going to get a lot more stars in the field, especially the darker and darker the location you go to. So that's kind of a cool thing about the double cluster is it's very easy to go out and observe. It's nothing fancy, but it really is kind of a wow factor object because there's so much you can actually glimpse in the cluster without a lot of work. If you're just getting started in astrophotography, it's also a great object that you can shoot from your backyard. It doesn't need any exotic, expensive filters because it's a simple cluster of stars. They're very forgiving objects to shoot. But that's always a good one to start with and kind of practice, getting your exposures right and the colors and stuff like that. So the double cluster is a fantastic object to work with, and I highly recommend getting out and actually trying to observe it when you have the chance. Right now, we're well into the season. It's a very, it pretty much will be up for pretty much all of autumn and well into the winter time. So here in the northern hemisphere, if you want to get out and observe it, you've got plenty of time to go out and view the double cluster right now. It's a great object to do as well for outreach programs because it's so easy to see in almost any kind of light pollution except maybe the most severe locations, but it's very easy to see. And it's got some really cool colored stars in there. So all right, so that's the double cluster. You can actually see right now that everything's playing nice and the images are stacking, you can see the contrast here is actually getting better. The background's getting darker. The stars are more pronounced. And this is a 61 megapixel camera. So the nice thing about this, we are running at 16 megapixels right now, but it gives us the ability to really dive down in to the clusters here and see all the stars that are down in there as well. So there's all kinds of stuff packed into these areas. So kind of a neat system there. All right, so that's the double cluster. Highly recommend it. Easy object. If you're getting something for the holidays or you just want to go out and do some viewing, it is a fantastic object to get your feet wet in for deep sky observing. So well worth it. Okay. Sorry. Tonight's momentum's been a little squashed because of our technical difficulties, so I'm going to try to drive this up a bit. The next one here is a big favorite. We did this last month, and it just looks freaking awesome in this telescope, quite honestly. This is the Pleiades Cluster, the Seven Sisters. I'm going to get this going here, and while we're doing that, we're going to talk about it. So we're already set. Don't need to do any fancy stuff with it. The Pleiades is in the constellation of Taurus the Bull. It's another very easy object to see, even from a light-polluted location. You can see this actually naked eye right now. It's currently rising in the east. It's fairly high right now, and it's going to look like a lot of people think it's the Little Dipper. I like to call it the Micro Dipper because it's not the Little Dipper. It's actually M45 the Pleiades. This has been known since the age of antiquities. 8th century BC to 6th century AD is about when that was. This was first referenced by Homer in the Iliad and the Odyssey around 750 BC. And it's actually referenced 3 times in the Bible, as well as other texts from Hindu and Islamic faith as well. A lot of us actually probably know it better as the Subaru logo that you probably see on Subaru cars all over the place. So it is something that we do see kind of in our daily lives. As far as Greek mythology go, this is the daughters of Atlas. And it wasn't until 1796 that this was finally designated M45 or the Messier. So let me backtrack real quick because you're probably hearing like NGC, Messier, blah, 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 all these catalog numbers. M stands for Messier, Charles Messier, who was a French comet hunter in the 1700s era, observing late 1700s. He was constantly looking for comets in the nighttime sky and ran across a lot of different things that weren't comets. And basically, to avoid those and not get them confused again, he made a catalog. This catalog is known as the Messier catalog, and there's a total of 110 objects in it. M45, or the Pleiades cluster, as you probably figured out, is the 45th entry into that catalog. And here is our view of that. So this is the Pleiades cluster right here, or M45. We're doing 30-second exposures right now. We're about two minutes in, roughly. And the detail that you see around it, this is actually the Merope Nebula is what that is known for, NGC 1435. This is a reflection nebula. And what's interesting about this is it's a beautiful blue nebula because the stars in the Pleiades are blue. And reflection nebulas are generally clouds of dust and gas that are floating. But what's interesting is professional observations have actually shown that the cluster and the nebula actually have nothing to do with each other in reality. It is simply the cluster passing through this dusty region that just happens to be in the area and is illuminating what you're seeing there. So it's kind of this interesting thing where basically what you're seeing is just happenstance of positioning between that. So this is the Pleiades cluster, the constellation of Taurus the Bull. We're getting really nice detail in the nebula right now. That normally is very, very difficult to do from in town because you have to fight light pollution and all this other crap that we have to deal with. From dark sky sites, this is a lot easier to do, thus the reason we're shooting from a dark sky location. But the fact that we're able to see this amount of detail in such a short amount of time is very impressive. So very, very cool object. But what's really interesting about some of this is the subtle detail. I'm going to go ahead and zoom in down here in some of the larger areas. But you can just see some of that structure there in the Pleiades or the Merope Nebula. Almost looks like paint strokes in a painting. But it's a very, very cool object. There's a lot of detail in there. And there's a lot of very nice images out there to really show you the color. We're using a black and white camera because they're more sensitive than a color camera, which allows us to get more into the detail of something a lot faster. So that's kind of a fun thing. But this is the Pleiades Cluster M45. It's an open cluster. There are two types of clusters in the nighttime sky. There are globulars, which we won't be doing any this evening. A very dense ball of stars. And then there are open clusters, which are a little bit more broad and spread out. The double cluster and the Pleiades happen to be open clusters. Globular clusters form a halo around the core of the Milky Way. And generally, the core of the Milky Way is actually visible more in the summer months, and most of the globulars clusters are also visible around that time. There's a handful that are visible right now, but most of the large, brighter ones are visible in the summer months and are not currently visible. But now we're looking at open clusters right now. And this is the Pleiades, one of the most well-known open clusters in the northern hemisphere. You can go out right now if it's clear, and you can see this rising in the east. It passes almost directly overhead for anybody in the northern hemisphere. And it's a fantastic object to see if you're starting to get started in deep sky observing, because it's very easy to find, lots of stars, and it's a stunning object to see from a dark sky site, because these are so many stars. And then you'll start to actually get some of that Merope Nebula that you're easily seeing in the image right here. And that's the beauty about using a camera, as the cameras are much more sensitive. They're able to bring out more of that detail that the human eye simply just cannot see. And on top of that, we're doing this with a 6-inch telescope. So that's a big thing there. So yeah, that is the Pleiades cluster M45 and the Merope Nebula there. One of the best, most observed objects in the nighttime sky, especially during the winter months. It's a fantastic object to go see. It's just one of those favorites that the minute you get into astronomy, it's something that you always will go back to throughout your entire observing career. Even if you do astrophotography, you'll probably shoot this thing over and over and over again as well. So very cool object, definitely worth getting out and observing it. Looks great in a pair of binoculars, looks great in small telescopes, and can get really interesting when you throw a big telescope on there and see even more detail. So it's exciting both at home and in dark skies. Fantastic thing to go out and actually observe at that point. All right, so we've done some pretty easy stuff right now. We're going to actually switch it up and go to our next target. And we're going to go a little bit deeper now. This is a fun one to do visually, but it is a bit of a challenge to see visually, because you're going to need a fair amount of aperture or larger diameter telescope to be able to get down. It's actually not too far from the Pleiades cluster either. And luckily, we're going to be able to stick with our same filter. So this is NGC, or New General Catalog, which is a very large catalog of thousands of objects. It also encompasses the Messier catalog of objects. So all the Messier objects have an NGC number associated with them as well. So this is NGC 891. It's what's known as a edge-on spiral galaxy. So galaxies come in all shapes, sizes, and forms. And also from here on Earth, we're able to observe them in various positions. So with that being said, this particular galaxy, NGC 891, is what's known as an edge-on spiral galaxy. And what's neat about these types of galaxies is from our position here on Earth, it's almost like you're looking down the edge of a CD or the edge of a pancake. So if you were actually to flip that on edge and look straight down, that's essentially what we're seeing here with NGC 891. This is located in the constellation of Andromeda. Lots of stuff floating up in there. It's about 32 million light years away from the Earth. So the light that we're seeing from this object right now, that little UFO looking thing in the middle, and I'll actually zoom in here. I'll blow it up a little bit to actually zoom in. So let me, and what you're going to notice about this is there's also a bunch of other galaxies that you will see that's very common when we're observing faint objects, is that we're able to see a lot of fainter things in there. Let me center this up right there. That looks pretty good. I'm going to stretch it just a little bit. There we go. Now we're cooking with gas. So this is NGC 891. It looks like a UFO. It has several different names, like a needle or whatever, but it's a very ghostly object to observe. A lot of the stars in this field are not tremendously bright, but they are brighter than the galaxy itself. So, and because the galaxy does have some of these bright stars in front of it, when you're actually looking for it, you have to be careful not to pan right over the front of it, because it's kind of nested back inside of the star field that it sits behind. So that's NGC 891. We're looking 32 million light years away from the Earth. So the light that left that galaxy, that is just getting to us right now as we're capturing these images, left there 32 million years ago. So it's a vintage, very nice, well-aged photon. Just what we want. And we're also, from edge to edge of the galaxy, we're looking at about 121,000 light years edge to edge of this UFO-looking galaxy there. Now, this one was also discovered by William Herschel. You'll find out that there's a handful of people that are generally responsible for finding all this weird stuff in the nighttime sky. Herschel obviously was a little bit later than Charles Messier, and he had access to larger telescopes there, so he was able to kind of look through and find a lot of these fainter things that Messier just simply couldn't see. So this was discovered in 1784 by William Herschel. It's somewhat low brightness, so it can be a little bit difficult to actually see this from without the right location and the right equipment. You probably need about an 8-inch or a 20-centimeter telescope to be able to spot this, and some good dark skies to actually see it. Obviously, larger equipment, larger telescopes are going to be more and more impressive on the view because they're gathering more light, and you'll be able to see some of the detail in that dust band that basically crosses across the galaxy center there. But it works really good. It's also a good challenge object if you're getting started in galaxies for astrophotography. It's one you can technically do from town. It's not tremendously difficult to do. And there's no real special filter that you need to do it. Galaxies kind of are a weird thing like that, where you really just need good conditions and the right equipment to be able to shoot and observe them. So this is a very popular one this time of year. It does get overshadowed by some of its brighter companions nearby, like the Andromeda Galaxy, which we'll get to in a minute. The Pinwheel Galaxy M43, which is also not far, also located in Andromeda. So there's two of the most observed galaxies in the nighttime sky not far from here. So this one at times can get overlooked quite a bit. It's also a lot smaller as well, so it's a bit more difficult to see. So that's why you don't hear about this one as much, but it is a very cool object because of just the look of it, and you know, that edge-on appearance is really quite neat. And there's a handful of galaxies up there. I mean, there's one right up to the left of it. See if I can grab the image here and kind of drag up. And this is what I'm talking about with galaxies. In the background here, this is NGC 891. There's a galaxy, there's a galaxy, there's one, there's another edge on. Here's some faint stuff back in here. There's some stuff. There's some really cool things in there. Let me see if I can actually pull some of this up while we're talking, just to see how far some of these little background galaxies actually are, because it gets kind of impressive when you're actually looking at some of these galaxies. I mean, we're already talking about NGC 891 down in that bottom right corner, which is, that's fairly far away as it sits on its own. Let's see if I can figure out which one of these. So this little spiral, face-on spiral, right up here, this is NGC 898. And let's see if I can get some information about that. That's about 270 million light years away. So this edge-on galaxy right here, so we're looking at NGC 891 over here. That's 45 million light years away from the Earth. This guy back here is 270 million light years away. So we're looking way out into space with these galaxies right here. And there's all kinds of really neat things as you progress further and further, and we shoot deeper and deeper, use larger telescopes. You tend to pull out more and more information, and further and further. This little faint guy right up here, this is PGC 9108. That's another galaxy. It's about 273 million light years from the Earth. So we're getting pretty far out in the boonies at this point with some of these really faint little things in there. Let me see if I can get us even further. This one doesn't even tell me how far it is. But there's all kinds of cool galaxies out there. So anyway, this is NGC 891. Fantastic edge-on galaxy. Bit more of a challenge. Probably looking at least an 8-inch or a 20-centimeter telescope from good dark skies. And if you have access to an even larger telescope and good dark skies, it's a very, very impressive telescope. But go ahead, give it a try. It's definitely worth doing. Really nice detail on that line, or the dust lane there. So it's a very, very cool object to see and also photograph. So that is NGC 891. Okay, I can talk a little bit longer now. Okay, we're going to go on to another galaxy. I've never done this one before. It was a last-minute addition. I have no idea how it's going to look, so we're all in the same boat together with this one. But this one is way down in the constellation of Fornax. And I'm going to go ahead and bring that up right here. So Fornax is not a common constellation that's talked about too much because it does not come very high above the horizon, and it's also a stick, essentially. It's not the most exciting constellation. It's 2 stars. So don't tell me how they got that. But, when you've got a lot of lead bowls and wine involved, anything can happen, right? All right, so this is our next target, NGC 1097. It's going to be a very, very cool face-on barred spiral. So it can be, this one will be an interesting challenge because it's low. It doesn't come up very high in the northern hemisphere, at least viewed here from the States. If you were actually further south, it would be higher and higher up in the nighttime sky. But it should be an interesting target to go after. So we're going to give it a go. Thought it was interesting. Has some really cool information on it. So we'll see what we can get out of it. I'm going to go ahead and get the camera going on it. And we're going to see what we get out of it. Because like I said, I've never done this one before. I've never observed this one before, even in a telescope. And it just seems like a really neat one. So this will be a first for most of us. Congratulations if you've seen this one before. If you haven't, well, welcome to the club. I haven't either. So, but there's a first time for everything. So on NGC 891, that was an edge-on spiral. So you're looking right down the edge of the galaxy there. This one, NGC 1097, is a face-on spiral. So imagine we took that CD or pancake or whatever we're talking about, and rather than do an edge-on like we were talking about with 891, we moved it and rotated it to where we were looking at basically the face. That's what we're seeing here with NGC 1097. 1097 is 45 million light years away from the Earth, and it spans 148,000 light years in diameter. This is another William Herschel find from 1790. Now, there's a lot going on with this particular galaxy. There's a lot of different structural things we want to pay attention to. We are fighting with a first quarter moon. You know, not a big deal for what we're doing tonight. But we're also shooting really low in the southern part of the sky. So I'm going to go ahead and zoom in on it, and I'm going to let the camera just kind of sit here and live stack on it and pull out some more detail, and we'll talk about this one. So NGC 1097 is a barred spiral, first off. So what does that mean? Let me break it down. It's a barred spiral face-on galaxy. So we already know what face-on means. It means from our observation point, we're looking at that galaxy in its full face-on position. So that's what we're seeing right there. That's why we're able to see all the spiral arms right there and all the detail. So great. That's what face-on is. A barred spiral, rather than looking like a whirlpool, a really even, symmetrical whirlpool, a barred galaxy has this kind of elongated center portion of it. That's where we get the term barred. So it's a barred face-on spiral. Now this one is really interesting because it has these beautifully intricate spiral arms that are just kind of dancing out towards the edge of it as it basically, you know, spins and hangs out through space. Now it also has a companion galaxy known as NGC 1097A, which is this little guy right there. That is the companion galaxy for this object. Now, there's a ton of stuff going on with this particular galaxy. First off, this is known as a Cipher Galaxy. These galaxies are a lot like quasars. If you're not familiar with what a quasar is a very, very, very distant object. Usually a galaxy of some kind that has a active nuclei. What that means is there's a black hole inside of it that's usually consuming mass and other material. So the thing with a quasar, though, is because they're usually so far away, the bright core of that hosting galaxy isn't actually observable to us. It's very difficult to see. A Cipher galaxy is basically something like a quasar, so it has an active nuclei, so there's black hole going on inside of there, but the galaxy is observable. So that is what NGC 1097 is a Cipher galaxy. It's an active galactic nucleus, so there's a black hole in it. This one happens to host a supermassive black hole that's about 140 times the mass of our sun. And what's really interesting about this is way down in this core, right down in here, is the black hole, right dead center in the middle of that galaxy. But that is actually, and you can kind of see this dark ring right in the center there. The black hole is actually surrounded by a ring of star-forming regions, which are known as H2 regions. They're heavily hydrogen regions where new stars are being formed. That region is about 5,000 light years in diameter, and it's basically a glowing red, because it's very rich in hydrogen, glowing red ring that sits around the supermassive black hole at the edge or the center portion of the galaxy. So that is NGC 1097 in the constellation of Fornax. Really interesting galaxy, has a lot going on with it. It does have that companion galaxy down there. It does have these really elegant spiral arms, and it's got a big old massive black hole going on in the core there. So this would be a cool one to try if you're into long exposure astrophotography. It does shine at a magnitude of about 10.2, which probably puts it in reach of about a 12-inch telescope. Obviously, bigger than 12-inch, this would be a good one to go after, but it does not get very high here in the northern hemisphere. So that's something to be aware of. If you're going to go out and try to observe this, you're going to need a fairly good southern horizon location there. So that's actually looking pretty good. You can get some of that really nice detail in there. You can see the spiral arms. But yeah, that's NGC 1097. Awesome galaxy. Try going out and observing that. That one's going to be a bit more of a challenge if you're new to astronomy. Like I said, you're going to probably need about a 12-inch telescope or bigger to really make it look awesome. I'm sure if you had a much larger telescope or got some good cameras on your telescope there, it would be an interesting one to go after. But it is a rather small galaxy, even in this 1,000-millimeter focal length refractor. But the window to observe it here in the northern hemisphere is rather small because it does not get very high above the southern horizon. And that's here in Arizona and Southern California, where the telescope is kind of located at. You don't have a lot of time, even being this far south, to get it. Southern hemisphere, just go to Australia. All right, so that is NGC 1097, very, very cool object. Now we're going to flip up to another Messier object. This one's a bit easier, but it's really often overlooked. I've overlooked this one for years. I've been doing observing since I was 9 years old, and it's one that I always forget about. But it's a very, very cool object. And that is that is M76, the Little Dumbbell Nebula. And this is a planetary nebula, so this is a first for this evening. We're going to see how it actually looks with the current filter, and then we'll see if we can do some trickery with some of our narrowband filters, because we're actually looking fairly high up in the nighttime sky right now. Let me actually show you where this guy is. M76. Nearly straight up. That's where M76 is right now. Technically, it's in the constellation of Perseus, but it's kind of on that boundary between Perseus, Andromeda, and Cassiopeia, almost. I don't know if I can do the boundaries on here, so that's fine. But we're going to see if we can get that to pop up here. There we go. Looks great. So this is the first planetary nebula that we're doing tonight. Now, a planetary nebula is basically what happens when you have a star that's about the mass of our sun, maybe a little bit bigger, that dies. So our star is not big enough to just supernova and go out with a massive bang. Our star will expand out and shed off its outer layers into space and basically just go poof. So that's all there is to it. That's planetary nebula. Nothing big, nothing fancy. But what's really unique about planetary nebulas is every single one of them is different. And that's goes without saying. M76 is no different because it has this double lobed feature. Normally they look like a sphere, thus the name planet. That's where they got their name, because they look like a planet in a telescope. But M76 is a double lobe planetary. So it's got the center portion here, and then it has these two outer lobes. They also call it the Cork Nebula. But this was originally discovered by Pierre Machon, which was Charles Messier's assistant. And this was in 1780. Now, it wasn't actually documented as a planetary nebula until astronomer Herbert Curtis observed it in 1918. That's when it officially got the designation of being a planetary nebula. So it's a really cool little nebula. Like I said, it's often overlooked. It is in Perseus. There's a lot of stuff in that region of the sky that draws a lot of interest. So this one doesn't get seen that much. Now, this is one of only 4 planetary nebulas in the Messier catalog. There's M27, the Dumbbell Nebula, M57, the Ring Nebula, M76, which we're observing right now, and M97, the Owl Nebula. Those are all 4 planetary nebulas in the Messier catalog. Now, there's thousands of planetary nebulas across the Milky Way galaxy, and then a lot of them are cataloged in various catalogs. But this is one of 4 planetary nebulas in the Messier catalog, which is one of the easiest objects, a list of objects to actually observe. Now, if we look really close, we're going to actually pump up the capability of this camera. Right in the center there, you'll see a little dot. Not a lot there, just a little bit brighter set of pixels than some of the other stuff there. That is the central star. This is the star that basically died and shedded off its outer layers into space. Now, this central star actually has a very high surface temperature of about 88,000 degrees Kelvin. That puts it about 158,000 degrees Fahrenheit. Eventually, though, this is going to cool off further, becoming a white dwarf over the next several billion years. So it's going to take a while. But what's interesting about planetary nebulas, and we're going to actually see if we can play with the filters here, and hopefully it doesn't give me crap. Planetary nebulas emit light in several different wavelengths. They're very abundant in hydrogen and very abundant in oxygen, double ionized oxygen. Now, we have filters in our telescope right now that can isolate those 2 wavelengths easily. So what we're doing right now is visible light. This is the light that the human eye all picks up. That's about what it would look like in a decent telescope. Now, what I've done is I've actually told the telescope to flip that filter out and put our hydrogen filter into the light path. And now what's going to happen is it's going to only let that hydrogen alpha band through, allowing our camera to see just the glowing hydrogen in the nebula. So in a minute here, what you're going to see is it's going to get darker, but you're going to see a shift where we're going to go from visible light to just isolating the hydrogen that's coming from this nebula. So you will be able to see some of the structure. There we go. So we can see right there, and this is where these filters kind of come in handy, because we can actually study different structures in a nebula. So what we're seeing right here is that the Little Dumbbell Nebula, or M76 that we're on right now, the core portion that actually links the 2 lobes of the nebula together is very abundant in hydrogen. Now, there is some outer arms in those little outer lobe regions that does have hydrogen in there, but the main portion, the main source of that hydrogen still stayed pretty close to the core portion of the nebula. Now, if we were to stop this, we can then flip that another filter out, and we'll put in our oxygen 3 filter. Oxygen 3 filters actually allow that double ionized oxygen frequency to pass through. So what you'll see here in a minute is we're going to be able to switch from looking deep into that core portion of M76, and hopefully we'll be able to bring out some more unique structures using the double ionized oxygen filter, or O3 is what we've designated it. So we'll let that come through, and hopefully what we'll see is a lot different structure come through because we're isolating another frequency of light. So we'll wait for the camera. It's going to make the switch here. Up pops the shot. There we go. So you can see that there's still some of these big bright regions in the core that are very, very active in oxygen 3, which is kind of in the blue portion of the spectrum, kind of green, blue, turquoise-esque. But what you do notice that's different from the hydrogen filter is those outer arm, or those outer lobes, are much brighter there. So having those filters to isolate different wavelengths allows us to study different structures and details that might be visible in these objects. And that's what we're doing right now. We're basically observing that, hey, these outer areas that have pushed away from the star are there's more presence of ionized oxygen, double ionized oxygen in that region, where towards the core, a lot of the hydrogen seems to have remained. And then there's other filters that you can obviously try as well. But these are 2 very, very common filters that are used. hydrogen alpha and O3. So it's kind of an interesting little project there. But that is the little dumbbell M76, about 5,600 light years away, 4.4 light years in diameter. It's kind of a cool one to go see, and like I said, it is vastly overlooked a lot of the time. So give that one a try. Go give it some love. You could probably do it in about a 6 to 8 inch telescope, even from home. Is something that you could do that with. So this next one is actually in our solar system, so it's going to be kind of neat. We're actually going to go after the planet Uranus. Get your Uranus jokes out now, because yeah, I heard it all day. Oops, we should probably have the telescope actually go find it real quick. Select target, slew. So the planet Uranus and Neptune are visible this time of year. Uranus is very easy to see. It's high overhead. I shouldn't say it's easy to see, but it is a good one to go find. It takes a little bit more work to observe the planet Uranus than it does, say, Jupiter, Saturn, Mars, Venus. All those are the naked eye planets. Uranus technically is a naked eye planet. I have seen Uranus from a dark sky site. It looks like a little star, and you need to know exactly what you're looking for. But we're going to go ahead and actually try this one. And there's no color on this camera, obviously, so we're just going to see what looks like a star. But we're going to try to actually look for the moons around Uranus. So while we're doing that, Uranus was discovered again by William Herschel in 1781. Now, Herschel originally wanted to name the planet after King George III. He wanted to call it George. Yay. That's exciting. That name, fortunately, didn't really stick. So later, another name, the name Uranus, was decided upon for the Greek god of the sky. And that's why thus the planet's name is that. Currently, as we're observing right now, we're looking at about 1.7 billion miles away from the Earth. There is the planet Uranus right there, with a bunch of little moons floating around it. I'm going to go ahead and stop, because unlike our fainter objects, Uranus is very easy for this telescope to grab. So we don't actually need to take any further stuff. That one 30-second picture let us capture the planet Uranus and some of its moons at 1.7 billion miles away. Now, the bright thing right here, that of course is the planet Uranus. That's about 31,518 miles in diameter. One of the largest planets in the solar system. I believe it's third in size after Saturn. So I believe it's the third largest planet in the solar system. Now, Uranus has a 17-hour day. It rotates very quickly. Its orbital period is 84 Earth years and has a total of 27 moons. So got a good collection going on there. Now, the interesting thing about Uranus is its angle. So Earth is tilted as it rotates around the sun. We have a tilt. That's why we have seasons. Same thing with Uranus, except Uranus has a tilt that is 97.7 degrees off from what it should be. So if this is 0, 97 degrees is, almost on its side. So effectively, Uranus is practically rolling around the sun, essentially what it is. So what's interesting about Uranus is the fact that its pole is always aimed towards the sun. And that makes it have very extreme seasons. So, and because it takes so long for it to orbit around the sun, one pole, like what we're looking at right now, one pole is going to be in the sunlight all the time. Well, that means the other side of the planet is going to be remaining in darkness for nearly 21 years until it makes that orbit around the sun and come back around. So if you can imagine, living up on the pole here on Earth, there's a lot of people, say up in like Alaska and more in the northern or the southern portions of the Earth, that the sun doesn't rise for a few months. And we're like, oh my gosh, that's a big deal. Uranus, you're talking 21 years of winter on, you know, if you're on the wrong side there. So that's crazy. Now, Uranus is also pretty interesting because it does rotate backwards. Venus and Uranus are the only two planets in the solar system that actually rotate the other way. So the sun rises in the west and sets in the east, or whatever that equates to when your planet is 90 degrees on edge. So kind of an interesting thing there as well. Now, Uranus also has two sets of rings. They're formed with ice and rock and debris from about 4.5 billion years ago when all this was actually together. And the planet is composed mainly of water, methane, and ammonia. And it is a gas giant, so there's no real hard surface to go there and land on. Now, when you actually go to observe Uranus in a telescope, it does look like a little pale blue little ball. Kind of a cool little object there. And the reason why it has that color is basically due to the methane gas in the atmosphere of the planet. Naturally, methane absorbs red light, resulting in that blue coloration because it reflects blue light. And that's why we've got that. Now, while we're on the target here, I'm going to go ahead and try to figure out which planet. I was hoping to see which moons were which tonight, but I don't think I have the orientation correct. But it has several moons there. That's what we're seeing right here, these little dots. Those are all moons around Uranus, looking at 1.7 billion miles away from us at this point. So that is the planet Uranus. Something cool, something new. All right. We're going to keep going on there because we are burning through time. And I do want to make sure we get to the last handful of objects. We're going to go up. I wasn't planning to throw this one in there, but it's such a good object. And it's one of the most known and observed galaxies ever. And it's still very well in season that we're going to go ahead and hit the Andromeda Galaxy. And the Andromeda Galaxy is known as M31 or Messier 31. It's the 31st entry in Messier's catalog. It also has two companion galaxies, which are M32 and M110. So we're going to go ahead and get that going. We're good to go there. This one is very, very impressive in this instrument that we're about to see. It fills the frame. So let's talk about it a little bit. The earliest known record of Andromeda comes from Persian astronomers in 964 BC. They called it the Little Cloud. The first telescopic observation wasn't even done until 1612 by Simon Marius. So, long time there. Many other observations and discoveries were made throughout the 1700s, but it wasn't until 1764 that Charles Messier actually found he cataloged Andromeda for the first time, and that's where we get Messier 31. And that was in 1764. Now, in 1785, William Herschel observed it and called it the Great Andromeda Nebula. They thought it was a nebula back then. It's not, as we know now. The first image of this wasn't captured until 1887 by English astronomer Isaac Roberts, showing the spiral structure, and that's where conversations started saying, it might not be a nebula. In 1912, you had Vesto Slipher of Lowell Observatory for Arizona, observed the spectrum of the galaxy and actually measured its velocity. And at the time, it was the highest velocity measured ever at that period of 1912. That was 300 kilometers a second. So they knew something weird was going on because they had the spiral structure. They had very fast velocity going on, so they knew there was something going on, that maybe it wasn't just a nebula that they were observing. I'm going to go ahead and stretch the image to bring up some more detail there. In the 1920s, there was this debate called the Great Debate between astronomers on whether M31 was a nebula or a galaxy. And then it was not until 1925 that Edwin Hubble, using the 100-inch telescope on Mount Wilson, just north of Los Angeles, finally proved through observations that M31 was much further away than anyone had expected it to be, and finally established that it was indeed a spiral galaxy and not a nebula. Now, M31 is suspected to form about 10 billion years ago and contains about 1 trillion stars inside of it. It has 460 globular clusters throughout it. Some of those are actually bright enough to actually observe in amateur telescopes. It has 2 satellite galaxies, which are plain as day in our image right now. We have M32 right down here, this little faint structure. And then we have M110, this little bit more diffuse galaxy up there. Those are its 2 companion galaxies. Now, M31 has also been proved through observation to be moving towards the Milky Way at about 100 kilometers per second. And that puts us on a collision with it and the Milky Way in about 2.5 billion years. So go ahead and mark your calendar for that. I don't plan on being here. Don't know about you, but I wouldn't worry about it. So that is M31. This is an easy target to observe in almost any backyard condition. It won't obviously look like this. You need to be in much darker skies to start to get the dust lanes and some of the little star regions inside the galaxy. But you can get the glowing core of the galaxy from an average backyard with even something as small as a pair of binoculars. But being able to go out and observe a whole nother galaxy is pretty amazing. It's also the furthest object one can see with their naked eye at about 2.5 million light years away from the Earth. So it's a pretty impressive thing. A pair of binoculars from a dark sky location on this object is unbelievable, because you really get the idea of how big this thing is in the nighttime sky. A telescope just doesn't do it, but a good pair of binoculars, 50 millimeter pair of binoculars from a dark sky, observing Andromeda, and you get to see just how expansive that galaxy actually is in the sky. It's pretty impressive. So that's M31, the Andromeda galaxy. Go ahead, check that out. It's floating up there, very well positioned this time of year. It's an excellent object to go out and observe. Or photograph. Best of luck to you. All right, we're going to start dumping off into the final handful of objects here. Let me see if we can actually find it. So I'm a big fan of really strange, off the beaten path targets. I like showing people just weird things. And a handful of those are the Abell Planetary Nebulas. So we looked at some planetary nebulas earlier at M76. That one was easy compared to the one we're doing right. This one won't be difficult, but this one's just different. The Abell Planetaries are very spherical planetary nebulas. They're a bit more challenging. Some of them are really challenging that require a fair amount of aperture or the right equipment to do so. But we're going to go ahead and try this one. This is Abell 12. It's in the constellation of Orion. And this sits about 6,900 light years away from the Earth. And it's called the Hidden Planetary, is how it got its name. And what's interesting about this is it sits right next to the star Mu Orionis, which is a 4th magnitude star in the arm of Orion. I'm going to try and see if I can show you guys where that is. Mu Orionis. So this star right here, it's literally like the joint arm portion of Orion. It's right next to Betelgeuse. It's a naked eye star. It's like 4th magnitude. You could easily see it with your naked eye from like an average sky. But if we actually take an image of it, this is the star field. There's an open cluster right over here. I'm not sure which one that is off the top of my head. There is the star Mu Orionis. And if we start to zoom in, there's kind of this weird little thing that sits next to it. It almost looks like a reflection, but it's not a reflection. This little thing right here is Abell 12, the Hidden Planetary. The reason, again, why they call it the Hidden Planetary is because it sits so close to this naked eye star that it's often overwhelmed or overlooked because it looks like a little reflection. But the thing about planetary nebulas is they are very, very active and abundant in double ionized oxygen. So they're also abundant in hydrogen, but oxygen 3 they're a little bit more abundant in. So I'm going to go ahead and flip in the oxygen 3 filter, and we're going to hopefully be able to pop this nebula out a little bit more. And this would be the same thing if you're trying to observe this visually with your eyes. You could probably do this in about an 8-inch telescope at a dark sky site, but like a oxygen 3 filter would be ideal. You could use like a UHC filter, but ideally an oxygen 3 filter is going to be able to pop that out more. Bring the shot up here. Everything should go a lot darker, but the nebula should be, there we go. It'll look a little bit better as it starts to do it, but that is Abell 12 right there, and the bright star Mu Orionis. Naked eye star, but that is Abell 12, the Hidden Planetary Nebula, and the constellation of Orion. I really like these objects that are kind of hidden in plain sight, right next to really bright stars. You get that contrast, but it's a really kind of a cool thing to do, and it doesn't take a whole heck of a lot of effort to actually observe this little thing. It's not ultra faint, and it's very easy to find because of how close it is to a very bright star. So that is Abell 12. You're looking about 6,900 light years away from the Earth, and the bright star Mu Orionis is actually a foreground object. The planetary nebula is a background object. So let me see if I can see real quick. I don't know the distance of Mu Orionis. I thought I had that down. So the bright star here, Mu Orionis, is about 155 light years away from the Earth. So the planetary nebula that we're seeing here is actually about 6,750 odd light years behind the star. So this is just an optical illusion to us. So the star is right here in the foreground and the nebula is here in the background. So it's kind of just an optical alignment that we're seeing here. But that's kind of a cool thing about it. So that's the bright star Mu Orionis and Abell 12, the Hidden Planetary. So go ahead, try that out. It's a real fun challenge target, and it's something that not a lot of people actually do. Even for imaging, you could do it from home. Those narrowband filters will do a lot of work to help with that. All right, we're getting to the last set of objects, and we're going to be playing a lot in Orion because there's all kinds of crazy stuff in the constellation of Orion. And one of them that we're going to try is very, very difficult, and we're going to see how this actually works from a dark sky site, even though we have a very, very bright moon up. I'm going to go ahead and kick the exposure up to a minute. Try to get a drink so I can get us through the last 30 minutes of this. For those of you who have been hanging out with me, thanks very much for hanging out on your Friday night. Hopefully you've enjoyed it. If you like what you see here, please go ahead and leave a like and subscribe to the channel. That way you know when our next one's going to be. Next month, we already have it scheduled. The link is already active. We're actually going to have Trevor Jones from Astro Backyard hanging out with us next month. So feel free to hop on, say hi, be a part of it, and hang out with Trevor and myself as we go through another live star party next month. So that is I mean, I should probably look this up real quick. That way I could promote it a little bit better. But that is our next virtual star party next month right here at the Focus Astronomy YouTube channel. And that is going to be for... anyway, it's already up there now for you to take a look at. That would be, January 7th. So join us January 7th. It's the first virtual star party of the new year. Hopefully, weather permitting, everything's going to be good. But yeah, we're going to have Trevor Jones from Astro Backyard hanging out as we go after some more cool exotic targets. All right, so we're on the Witch Head, and you can just start to make out some of that cloudy detail in there, right up in here. Very faint object in the nighttime sky, right up in the constellation of Orion. We are looking right over here, right off the bright star Rigel. Here's the witch head right over here. It gets its name because of that. Obviously, it looks like a witch head. Here's the nose, here's the lips, here's the chin, and that is the witch head. Witch head is a very, very difficult object to do just about anything with. Let me see. Abell 12. Abell 12 should actually be in Sky Safari. I use Sky Safari Pro. It does come up in Sky Safari Pro if you're looking for Abell 12. But if you're not using Sky Safari Pro, then I don't know if it won't come up. But I know for a fact in Pro, it does come up because I just searched it there. So it came up no problem. But you might need the Pro edition to do that. There's a lot more objects in the Pro version. So this ghostly nebulosity that you're starting to see in your image right there, and normally to get a nice image of the witch head, we're talking multiple 5-minute exposures or very long, deep exposures. But you can just start to see that ghostly nebulosity come out here. That is the witch head. This little bubble up here, it's not a UFO, so don't worry about it. It's a dust bunny on the sensor. That happens when you take astrophotography photos. There are ways to calibrate that out of the image. But this is the Witch Head Nebula. This is exceedingly difficult to observe. The Witch Head is a reflection nebula that has bright light being reflected off of the dust particles that reside inside of the nebula. And that light is being reflected from the bright star Rigel. Now, the Witch Head Nebula is huge. It's about 2.6 degrees in size as far as the nighttime sky goes. So you're talking about five full moons in width. It's huge. It's a very difficult nebula to observe. You generally need to go out and have some very, very dark skies. There's no filter that can really help you here. It's just all about having the right conditions to see it. Now, like I said before, the dust particles that actually compose the nebula generally reflect blue light from stars, and that's why if you actually see a color image of this, it's a very bluish, ghostly blue coloration. That's because a lot of the particles that make up the nebula here reflect blue light a lot better than they do red light. Now, radio observations from radio telescopes have observed this particular object and have found the nebula to be very rich in carbon monoxide. This leads to details confirming that the nebula is hosting molecular clouds, which allow the birth of main sequence stars like our sun to actually occur. And they have found these pre-main sequence stars in the nebula deep inside these clouds. So there is some star formation going on in this nebula. It's pretty interesting structure in the sky there, but very, very difficult object to see visually and something that takes a fair amount of time to actually get a really nice image on. And our telescope here cannot even fit the whole thing in the field, but you can start to see that witch head. There's the lip area, there's the nose, and then there's all kinds of very elegant detail to catch in there. So very, very cool object, just very, very faint and very difficult to see. But that is not going to be the case for our last two targets that are up tonight. So the last two are the most observed objects in the sky this time of year. The first one, of course, is the famous Orion Nebula. This is probably the most observed and most photographed object in the nighttime sky. And it's because it is so bright and easy to see that the Orion Nebula is the way it is. So the Orion Nebula, M42, 1,600 light years away, 35 light years in diameter. History of this thing. There have been tons of observations about the constellation of Orion throughout history. The Mayans, Ptolemy, Tycho, even the Bible mentions the constellation of Orion. Galileo has observations of stars within Orion. There we go. There's Orion. There's a ton of satellites going through there. 1, 2, 3, 4 satellites going right through the Orion Nebula there. But that is Orion. The Orion Nebula. Orion is this portion right here. Then we have Messier 43 here, and then we have the Running Man right over here. So this is the Orion Nebula. But going back to the history books real quick, like I said, there has been multiple observations of the constellation of Orion documented throughout history. Like I said, Mayans, Ptolemy, Tycho, biblical, Galileo, all of that has documentation of the constellation and stars within it, but none of them documented the nebula. And the nebula can actually be seen somewhat naked eye from dark skies. And back then, obviously, when there wasn't any street lights or any major light pollution, you should have been able to see the faint glow of the nebula hanging out in there. So the nebula wasn't actually documented until 1610 by Nicolas Claude Fabre de, I'm going to butcher this last one, Pierist of France. Turned his telescope to the sky. But the problem there is he didn't document this well. He only reported that he saw it. So he wasn't officially, I guess he did discover it, but there was no real documentation behind it. He just reported that he saw something cool. It wasn't until a year later in 1611 the first documented observation of the nebula was made by a Jewish astronomer. Jesuit astronomer Johann Baptist Sayest in 1611 actually documented observations of the Orion Nebula. And then shortly after that, there was another gentleman who actually did the first drawing of the Orion Nebula, but unfortunately over time that was lost. Now, fast forward a little bit further, it wasn't until Christian Huygens actually sketched the nebula in 1656 that was the first documented sketch of the Orion Nebula. Now, that's kind of a big deal because now we're actually getting documented, but real quick. Oh, if you're trying to find Abell 12, it's Abell. There's 2 L's in it. So if you type in Abell, it's not going to show up. Abell is 2 L's. So try that. Let's see. Back to my stack here. We're going to go ahead and stretch this out a little bit. Well, too much. There we go. Okay. So, first documented sketch in history of the Orion Nebula was 1656. Now, here comes Charles Messier. In 1716, he finally added this as his 42nd object. And it wasn't until a little bit later that this little portion down here, this little bubble called Messier 43, he eventually went back and documented that as well. But he first mentions this early in the 1700s in his observations. Now, he also observed that there's a small cluster that's sitting in the middle of the Orion Nebula in 1769. This is called the trapezium. And the trapezium is the reason why all of this nebulosity actually glows. And a lot like a neon sign actually does. Now, finally, the first image of the Orion Nebula was taken by Henry Draper in 1880. And that right there is where some of the basis of modern day astrophotography actually started for deep sky targets. What we're doing right now sits on the footprints of Henry Draper's shot in 1880. Obviously, we're using much more refined equipment to be able to do what we're doing right now. But the fact that we're able to do that is very, very impressive. Now, M42 is the brightest nebula visible in the northern hemisphere, and it's very easy to observe. It takes very, very little effort to do this from nearly any location. Pair of binoculars will show you the nebulosity, and obviously the larger the telescope or the optical system, the more and more detail you'll be able to see. Now, from a dark sky location, it's even more impressive. I'm going to go ahead right now, because we're on visible light, I'm going to go ahead and flip to the hydrogen filter. This area is part of a much larger region called the Orion Molecular Cloud, or OMC1, which is a massive cloud of hydrogen that basically encompasses about half the constellation of Orion. And it encompasses the Orion Nebula, the Horsehead Nebula, which we'll get to in a second, as well as some other nebulas that are in the region. And it's extremely abundant. So Orion isn't really just the nebula in Orion. The Orion Nebula is basically just a dense portion of this much larger structure. And there's a lot out there, floating out there. I'm going to see if I can find my image of this real quick, just to show you guys what it actually looks like when you've gone through and sat there for hours taking pictures over and over and over again of this thing. And it's there's just a lot up there. It's really an impressive thing up there. So I'm trying to see if I could find let's see. But anyway, Orion is a very easy object to go out and actually observe and photograph. You can do it from home. You can do it with a DSLR. You can do it with some real basic stuff out there. So here is a colorized version of the Orion Nebula shot with this same telescope. You can see all the hydrogen that's sitting in there. But that is actually a color image of the nebula we're actually observing right now, taken off of this exact same telescope. So pretty neat system right there. Let me bring this back up real quick. There we go. So there's the Orion Nebula. There's the Running Man Nebula. These are things you can easily do at home, especially if you've got a nice set of the narrowband filters that we were talking about earlier. These little things are very helpful. But it's easy to do with a DSLR camera and a little tracker, or a nice telescope will do that too. But that is the Orion Nebula. It's a star-forming region in the constellation of Orion, probably the most photographed object in the nighttime sky, and it contains about 700 stars total. All right, last object of the night is the Horsehead Nebula. Now, Horsehead is another object that is photographed God knows how many times, but it is not easy to observe it at all. It's a very challenging object to see, and it does require very dark conditions, generally larger telescopes, probably at least a 12-inch or bigger. But yeah, there's a lot going on with that. So the The Horsehead actually has a couple different things. I'm going to try to break it down. It was officially discovered by William Pickering in 1889. And it wasn't until about a year later it was first recorded by a Scottish astronomer, Wilhelmina Fleming. Officially documented it on a photographic plate at Harvard College Observatory. The first description of the nebula wasn't done until 1913 by E. Barnard, who was doing photographic plates of the region and was showing it a little bit more. So I'm going to try to stretch this up a little bit. There we go. Now, we're using our hydrogen filter right now. That's the easiest way to get this to come out because of how difficult it actually is to get. This is actually fairly easy to do with a hydrogen alpha filter, and there's a couple pieces I want to break down. So a lot of people refer to this nebula as the Horsehead. That's kind of accurate, but not completely accurate. The Horsehead is just this dark pillar right here known as B or Barnard 33. It's E. Barnard's 33rd entry into his catalog of dark nebulas. Now, the Horsehead portion itself, which we can see right there in the center of the frame, is actually silhouetted against this other nebula, which is known as IC434. That's this emission nebula right here that the Horsehead is silhouetted against. That is IC434. Very easy to get with a hydrogen alpha filter. You can do this from your backyard on a full moon night if you've got a hydrogen alpha filter on it. It's a very fun one to go out and check out. Now, it's hard to see right now, but just below that, this little bright star right here is actually encompassed by another nebula. And if you ever start taking pictures of this object, that is NGC 2023, which was discovered by William Herschel in 1785. And then a year later, Herschel discovered the Flame Nebula, NGC 2024, which is also an emission nebula. There's a lot of crazy things going on in this nebula as well. Inside this Flame Nebula right over here, this is also part of the OMC or Orion, Massive Orion Nebula Complex. The Flame hosts a small cluster of newly formed stars. About 86% of these stars actually show circumstellar disks around them, which are actually the precursor for formations of planets to occur. So there's a lot of formation going on inside of the Flame Nebula that was done in like infrared photography and stuff like that. So that's kind of neat to see there. Now the Horsehead itself, this dark region right here, if you're trying to observe this with your eye, you really need what's called an H-beta filter. And you really do need some dark skies and about a 12-inch telescope or bigger. It's very, very difficult to see. It's kind of like a black thumbprint on very dark gray or black paper. You really have to take your time going side to side. And what you're actually looking for is you're looking for IC434, this nebulosity that the Horsehead's backed up against. You're looking for that. And then in the middle there, you're looking for the lack of light. And that's basically what the Horsehead is. The Horsehead is a dark nebula. It's a dense cloud of dust and gas that's preventing the light from the background stars or nebula to push through. So you're looking at a silhouette, essentially, is what we're doing there. IC434 is a large emission nebula. It's a star-forming region just like Orion. Just Orion is a lot brighter and bigger. And they're both about the same distance. Now, the nebula itself is actually lit by a multi-star system called Sigma Orionis. It's not lit by this star right here. This is Alnitak. Alnitak is a naked eye star that's famously part of Orion's belt. You could probably walk out in your back right now and look at that star naked eye with no extra optics needed. However, as bright as Alnitak actually is, and if you ever look at pictures of the Horsehead Nebula, it's easy to see, but if you ever see it, Alnitak has nothing to do with the Horsehead Nebula. It's actually nearly 1,000 light years in front of the nebula structure itself. So again, it's kind of like that Abell 12. It's more of an illusion where one's in the back, one's in the front. So, but it's actually a cluster of some stars that are illuminating this whole area. And then Alnitak, as big and bright as it actually is, actually has nothing to do with it. It just happens to be in the frame. So anyway, that is pretty much it for tonight's broadcast. We did go a little bit long, but thanks for hanging out with me tonight. Hope you had a good time. Our next one is, I believe, January 7th. We're going to have Trevor Jones from Astro Backyard hanging out with us. So thanks for being with us. Have a great weekend. Stay safe and clear skies to all of you. And we'll see you all next month. Take care, everyone. See ya.